Hi, I'm Adam Stanley from the 3D Measurement Company and welcome to another 5-Minute Friday. So this week's topic has come off the back of two demonstrations we've done this week. It's been completed with our handheld portable laser scanners. So for those of you who don't know, our AXE and our KSCAN range of 3D scanners both come with integrated photogrammetry. So it's a dual system, 3D scanning and photogrammetry in the same device. And so that's the topic today, it's photogrammetry. And more importantly, why it's a technology it's very important to understand when it comes to 3D scanning techniques. First off, we should start with what is it? What is photogrammetry? Textbook definition really is the science and technology of obtaining reliable information about physical objects or an object through the process of recording, measuring and interpreting photographic images, so 2D imagery. Before we go any further, let me show you what that means. We'll take a look in our measurement lab and I can show you exactly what that is.
So we're in our measurement room here at the 3D Measurement Company, where I can show you some of the bits and pieces that exist within the photogrammetry system. All of our measurement devices here pretty much use photogrammetry from one time or another, dependent on the project. We have a large project behind us, which we'll be setting up photogrammetry on. So a very basic principle for photogrammetry is known information within a 2D image. So we have barcodes that we would apply to a surface. These are magnetic and these just can be placed randomly on a surface and they get captured by the handheld scanning device with that integrated photogrammetry. Critically for the process, we have scale. Now these are calibrated ISO 17025 calibrated carbon fiber scale bars. These are a known nominal distance that we can cross-check against during a photogrammetry project. That's what gives us our increased accuracy for a measurement project.
So I've shown you very quickly the setup for it. So why is that important? Why should you guys really care about photogrammetry? Well, first of all, it's important to understand that photogrammetry captures a larger field of view than 3D scanning. And because of this, it's able to more accurately capture those reference markers that I showed you that we use for 3D scanning. It does this by increasing and varying the angle at which the camera sees those reference markers and those barcodes. Because it's a singular camera, we're able to move it around a little bit more independently of the other camera position because it's not by definition locked to a stereo camera setup. So that makes the calculation of all those points more stable. In addition to this, because the measurement volume is larger in a photogrammetry system, we can actually introduce a larger scale into that measurement, which are the scale bars that I showed you, those reference carbon fiber bars. Larger scale bars in a measurement of any kind will mean a greater accuracy for that overall project because there is a larger known size within the measurement project. So if you have a 1 meter part and you have a 1 meter scale bar, it's going to be a very accurate representation of scale versus a 10 millimeter scale bar in a 1 meter project, if that makes sense. And that can be sort of linearly extrapolated up to a much larger side. But there's more to photogrammetry than just that. If you want to just simply 3D scan an object and add reference markers as you go along, which you can do when you're just using a 3D scanner, it's perfectly fine for a small component that fits within sort of the natural measurement box of the scanner. But if you add those reference markers on a bigger part, not only are you adding an unknown stack of error into the project, but also you need to add an awful lot of dots to the project, as you have to have a crossover of dots visible to the scanning device to move from one location to another. If we use an example here of a car body or a vehicle body, if you wanted to scan the front and the rear of the car relative to one another, without photogrammetry you would need to apply dots the entire way along the surface, effectively joining the front to the back. With photogrammetry, you simply need to apply the reference markers, which position the 3D scanner in space. You simply need to apply those in the region that you're interested in. So you put some in the front and you put some in the back. So in this instance, you would be saving nearly I don't know, 75% of the dots needed to complete the project, because you're not having to stitch one area to the other. The photogrammetry as a global measurement takes care of that before you get to the scanning stage. So that further reduces your consumables uses, which is, as you guys know who are using handheld scanners or any scanning technology, is, you know, it's an important thing to consider. But photogrammetry also plays a huge role in what we call measurement reference frames. You may know them as fixtures for holding parts. If you have permanent points on a fixture or measurement reference frame, whatever it is that you want to call it, and the fixture is in a stable environment itself, so maybe an inspection lab, then these reference points can be very quickly and accurately captured using photogrammetry, which affords an accuracy of approximately 15 microns per linear meter. Then you can set these as a reference project for the frame. So then you're in a position that you can just load parts on and off the fixture quickly and repeatedly, helping to increase process efficiency. So the person who's in charge of that simply needs to scan. There's no setup then, don't need to place dots on the part. So it also reduces human error and will also improve measurement accuracy, because you're using this photogrammetry technique, which is a higher accuracy than scanning. The real takeaway here is that photogrammetry, it is a big deal for 3D scanning, but it's almost never talked about. I went to 2 demos this week for technical presentations of quality and inspection using 3D data captured from a handheld device. But upon talking about photogrammetry and how having it integrated into the scanning device and why that's important and a big benefit to them as a business, I was met with blank faces as to what photogrammetry really was. After a short demonstration and discussion about it, they all recognised how powerful this could be for their workflows going forward, and for flexibility of being able to measure small parts and very large parts in kind with the same system with greater accuracy. But it made me want to then raise this with you guys, because it's perhaps not talked about enough and not recognised enough of why it's so important to use photogrammetry with 3D scanning to improve your project. If you watching, any of you are using 3D scanning for quality inspection and for design purposes, then I am confident that there would be an instance where photogrammetry could help. We actually have a great article around this subject that was written about a project we worked on sometime last year using one of our KSCAN systems, and how the use of photogrammetry within that system solved a really long-running issue with an elite car company who had previously just been using 3D scanning on its own to capture the full geometry of the car, where they were finding when they were doing redesign and then 3D printing very large components to fit into or onto the exterior body, there were huge errors, big gaps where there shouldn't be any gaps. So we were able to help them solve that issue, and it came down to accuracy of the scan. I'll put a link below. It's definitely worth a read, and as ever, if you've got any questions, then please get in touch with me either directly or with a member of the team. That's it for this week. Thank you for your time. I'm pretty sure I went over 5 minutes, but photogrammetry is such an important topic. I could go on for several hours really of how photogrammetry is the best kept secret within the 3D scanning space, but we'll cap it there. If you have any direct questions, then fire them over, please do. Thanks for taking the time to watch the video, and I hope to see you on the next one. Take care.